Hello Julian, welcome to this short video lesson, and I believe we are done with most of these problems and we are just going to try out this portion that's under try this. It says use triangles ABC, so we have ABC over here and A prime, B prime, C prime. A prime, B prime, C prime is the larger triangle. To complete the following, for each pair, that's number 1, for each pair of corresponding vertices, calculate the ratio of the x coordinates and the ratio of the y coordinates. So we are going to come up with a table or a chart pretty much like we did on the previous problem, which is over here. So let's do that. Okay, so we have a chart over here. Now we have the vertices or each vertex A prime, B prime, C prime as on the outer triangle, and we will note down their x and y coordinates. So this is going to be the x coordinate of A prime, y coordinate of A prime, similarly x coordinate of B prime, y coordinate of B prime, x coordinate of C prime, and y coordinate of C prime. And we are going to do the same for the inner triangle, that's ABC. So x and y coordinates of point A, of point B, of point C, and then we are going to go ahead and find the ratio of the x coordinates, triangle A prime, B prime, C prime to ABC, and ratio of y coordinates A prime, B prime, C prime to ABC. So this one is going to have the ratio of the x coordinate of A prime to that of A, right? So this is how we are going to fill up the chart or the table. So let's go. A prime is negative 4, 4. So we have negative 4 for x and 4 for y. If you look at B prime, that's 4 and 2. So I'm going to write 4 and 2 over here. And finally C prime is negative 2, negative 4. So we have negative 2, negative 4. Now let's move on to the inner triangle ABC. A is negative 2, 2. So let's write that down. X is negative 2 and y is 2. Similarly B is 2, 1. So we have 2, 1. And finally C is negative 1, negative 2. So we have negative 1, negative 2 for C. So under x coordinates we do A prime to A. So this is negative 4. X coordinate of A prime is negative 4 over the x coordinate of A is negative 2, and negative 4 over negative 2 is 2. Similarly for B prime to B we have 4 over the x coordinate of B is 2, 4 over 2, and that's also equal to 2. And for C prime we have negative 2 over C is negative 1, and that's also equal to 2. So all these three ratios are equivalent to 2. How about the y coordinates? The y coordinate of A prime is 4, so we have 4, 2. Y coordinate of A is 2, so we have a 2 over here. Y coordinate of B prime is 2 over the y coordinate of B is 1, and 2 over 1 is 2. And finally the y coordinate of C prime, as we see, is negative 4 over the y coordinate of C is negative 2, and that's also equal to 2. So I think that concludes part 1. For each pair of corresponding vertices we have been able to find out the ratio of the x coordinates as well as the ratio of the y coordinates. Now for part 2, is triangle A prime, B prime, C prime a dilation of triangle ABC? Yes, indeed. The larger triangle is a dilation of the smaller triangle, because the dilation factor, this is what we call the dilation factor, this ratio, and the dilation factor is constant, that's 2. So we could say yes, triangle A prime, B prime, C prime is a dilation of triangle ABC because the ratio of the x coordinates and the ratio of the y coordinates are equal for each pair of corresponding vertices. Done? Alright, so that's it. This is the only problem we were left with, and I'm going to see you as usual on Thursday.